It means high precision one. We call it GNSS with different satellite systems.
So it's these different things here. This is interesting as well.
Many people ask.
Ja, liebe Freunde, neben mir steht Jackie Chan.
Okay.
Jackie Cheung.
Thank you.
And er wird etwas über uns, er wird etwas erzählen, was er hier macht. Und zwar geht es darum, die machen ein Mapping, die fliegen mit einfacher Linse oder mit 3D-Linsen, das werden wir sehen, mit 5 Linsen, die auch schräg dran sind, und mit einer hochpräzisen Höhenbestimmung für die Kameras, die als eine Linse funktioniert, aber sie hat GPS, der GLONASS drin, das ist dieses, the Russian one, the GLONASS
Yes,
is
yes.
Russian, and the Chinese one,
Satellite system for global use.
and Galileo
From European.
yes, und Galileo ist später. Aber damit hat man auf jeden Fall mit den Einlinsen, die auf GPS basieren, hat man 10 Meter hoch und runter. Und mit dem Zusammenmixen der verschiedenen GPS-Funktionen oder des Global System, Navigation Systems, hat man die Möglichkeit, eine unglaublich hohe Auflösung zu bekommen, weil man aus den verschiedenen Satellitensystemen die Position bekommt. So, we're talking in English now.
Okay.
I make the introduction for our community. And tell us something about the one lens way here to fly and to make the mappings.
So we are a professional manufacturer for survey equipment as well as GIS solutions provider from China. So we came here to introduce our models particularly for high precision surveying and mapping, and then as well as other related applications like traffic control or precise agriculture, power line inspection as well, those kind of things. And then our models belong to the professional grade field, unlike the small ones for consumer entertainment, And then that's why you see the size and like this, right? Not that small. So
you can use a drone for different ways. How you manage that? Do you have?
see it?
Yes.
This is a open structure design,
Yes. Okay.
right? We have double decker,
Yes.
yeah, with guide rail connections.
Yes.
Then we can plug in,
Everything.
connect it, and then screw in, connect. Also, we can remove this cover. Yeah, so this model can carry a lot of things. Yeah.
Is it possible to put it in your hands?
Yes, of course.
Yes.
It's just less around 2.6 kilos, not that heavy. It's an integrated system made with professional cameras.
What you can do with that?
You see it? 3D modeling. 3D modeling. Normally, for the standard models, we can have 2-dimensional outputs. But with this thing, with this camera system, we can see the objects from the sky in different directions. And then we integrate all things together to make a 3D modeling.
Okay.
For example, when we ask anyone, you prefer 2D or 3D? Of course, that's tailored to human visions, right? Why not?
Perfect.
Like that.
And you make clouds with them?
Yeah,
yes?
different. See, different.
Yes.
Different kinds
You have the point clouds?
Yes.
And then you can make the 3D virtual objects.
Yes.
Okay.
It's another type of output only.
Okay. So you have the overlap for that of the photos, the special overlap, and then you take Agisoft or something like that to make the mix. Okay.
Actually, outputs are related from the software part.
I know.
This is the device who help us to have the imagery.
Yes. And then you get the right position in the air
Yes.
with the lens, and everything is working on the software and ground.
Yes, of course.
I understand what you mean. Okay, so let us go to the next point here. Introduce us about this system here.
This is new devices we introduced together with our standard version. You see it, the small box here, but in future we will minimize and make it much smaller to include inside. there will be one professional GPS mainboard inside. This mainboard will connect those satellite systems. We call it multi-constellation. GPS, GLONASS, Galileo, and BeiDou, 4 global satellite systems all together. Then with this system, we can have high precision aerial photogrammetry in the air. Normally for standard models, only at several meter accuracy.
Yes.
But with this, we can have the result down to 2 or 3 centimeters for the best points. Okay. Yeah. See it? This is a Steadicam system for the camera gimbal. It's quite used in the cinematography.
Okay, no?
Yeah. No matter how it tilts in the air, the camera still remain vertically to the ground.
Yes.
So the photos are always flat, not like this.
It's okay.
Yeah, when all the imagery are good quality, then we have a very good result of the map.
And the main thing is that you get the very accuracy data for the camera lens, and you know that where the position in the air exactly was, so your measuring is very correctly.
Yes.
Yes, okay. So here's a one lens drone.
Yes.
What's the way you put it away and it's flying the waypoints and something like that?
As we know, the UAV business firstly started with this kind, fixed wing type, right? And then after some years, the multi-rotor came.
Yeah, okay, the multi-rotor, right? Okay.
So we use both models for mapping, but this one is lighter, much lighter. It's just 2 kilos around, right? And it flies faster in the sky. Mainly, it do the mapping for us. But that one, we can do a lot of things. Depends on the structure, right?
So, thank you very much.
Yeah.
Nice.
Welcome.
And this was a very interesting point to measure many different global navigation systems together to get a very accuracy point. So, thank you, and have a nice fair and big success.
Yes, thank you so much.
Bye-bye.
Thank you.